For an example with this idea, we have that in 2000, 38% of young adults aged 18 to 29 lived with their parents. In 2020, 52% of young adults lived with their parents. Use this information to find the slope of the linear function representing young adults living with their parents and describe what it represents. So here, we're thinking of this in the same sort of way that we had with our last application from the previous section, and in this way, we can translate our information into 2 points, 2000 for the year 2000, and 38 to represent the percentage living at home, along with the point 2020 and 52%, where it might be worth noting that there are some very complex and involved socioeconomic and health reasons why in 2020 that number might be much higher, but there actually has been an upward trend even before we got to that year. Anyway, in this case, we want to get the slope m. That's just going to be the same as it is always, 52 minus 38% over year 2020 minus year 2000, which would end up giving us 14% over 20 year, or 0.7, which is to say that each year, starting from the year 2000, we can expect what would that end up being? Actually, let me change my phrasing there. We can expect, not because that would imply a rate that I don't want to, we can expect an increase of 0.7% in terms of the number of young people still living at home. That percentage will go up each year by about another percentage point based on this slope, based on this projection that we're making, where I've talked about this sort of idea before. This is fairly simplistic. It doesn't take into account any of the factors for why this happens, and for that matter, it would imply that at some point before the year 2100, more than every young person would be living at home, which can't happen. But we do get something in terms of making a projection, something in terms of a model from that slope. Still fits into the idea of why we care about slope. And the last thing we'll see for this section, is a bit of a callback to the idea of difference quotients that we talked about earlier. Because technically speaking, every time we talk about any slope computation, that is a kind of difference quotient. It is a quotient of differences. So we're going to see how this comes back together with an idea called average rate of change.